Welcome back. This is the third video on graphing quadratic equations. So in this video, we're going to look at how to put a quadratic equation into vertex form. So we saw a video how to graph a quadratic equation if it was in standard form, and then we saw how to graph a quadratic equation if it was in vertex form. But now let's see how to get from standard form to vertex form, because vertex form is much easier for sketching the graph of a parabola. Okay, so let's start with this example, number 3 on lesson 20. It says, it has multiple parts. It says let y equal negative 2x squared plus 4x minus 4. So this is in standard form. And it asks us a couple of questions. So the first question is, does the parabola open upward or downward? How can you tell? So we've seen in a couple of previous videos that we can tell the direction of the parabola by the number a. The first number, in this case, a is negative 2, b is 4, c is negative 4. So a is negative 2 tells us that because it's a negative number, the parabola is going to be opening downward. If it were positive, we would know it would be opening upward. Okay, so now part B says complete the square to put the equation into the form y equals a times x minus h squared plus k. So remember completing the square. This is where it comes in handy. So the first step is to look and see if the x squared term has a number in front of it that isn't positive 1. If it is positive 1, then we just start by isolating the variable terms and completing the square. But if it's not a positive 1, then we have to divide the first two terms, the variable terms, by whatever that number is. And we can see that the number a is in front of x squared, and it's negative 2. So we're going to divide the first two terms, the two terms that have variables in them, we're going to divide both of them by negative 2. So that means we're factoring out the negative 2. We're not dividing both sides, we're just factoring out the negative 2 in the first two terms. So we get negative 2 times x squared minus 2x, and we left a little space, and then outside the parentheses, we still have the minus 4. And double check my factoring, make sure I factored it out correctly. If you multiply it back together, we should get negative 2x squared plus 4x. If you multiply that negative 2 back in, make sure I did it correctly. Okay, so now we're going to complete the square inside the parentheses. But we have to make sure our equation is balanced. Whatever we add to the right side, we add to the left. Or the other thing we can do is if we add something to the right side, we have to remember to also subtract the same thing from the right side. Okay, to keep everything balanced. So we look at the x term, the coefficient in front of x is negative 2. We take half of that, we get negative 1, and we square that number. We get positive 1. So we're adding positive 1 inside the parentheses. But what have we really done to the whole right side of this equation? We haven't really just added positive 1. We've added positive 1 times that negative 2 that's out in front. So we've actually added a negative 2 to the right side of this equation. So what we can do is we can add a negative 2 to the left side, or we could just subtract a negative 2 from the right side. Okay, if we added something to the right side, we can also just balance the equation by subtracting that thing. So I'm going to add a positive 2 to the outside of the right side. Okay, because I added a 1 times negative 2, I need to also add a positive 2, because then I'm just really adding 0 to the right side of the equation. All right, so now let's rewrite this so that we have a perfect square trinomial. So the trinomial x squared minus 2x plus 1 is really x minus 1 squared. We still have a negative 2 out in front. And then negative 4 plus 2 leaves us with a negative 2. So this is now in vertex form. So we can see that if we rewrite it just a little bit, we can see what A, H, and K are. And now, even though it didn't ask us to do that, we can write down the vertex of this parabola. The vertex is going to be the point H, comma, K, so in this case it's 1, comma, negative 2. All right, so completing the square gets us from standard form to vertex form, and then vertex form gives us a lot of information about our parabola. Okay, part C says find the y-intercept, and it's the same as with lines, with any kind of graph. Whenever you're looking for the y-intercept, you just plug in x equals 0. So let's plug in 0 for x. We get y equals negative 2 times 0 minus 1, quantity squared, minus 2. So 0 minus 1 is negative 1, but when you square that, you get positive 1. So you really have a negative 2 minus 2, which gives us a negative 4. So the y-intercept is negative 4. We can also write that as the point 0, comma, negative 4. Okay, so let's keep moving. Part D says find any x-intercepts. And the way to find an x-intercept, or any x-intercepts, is to plug in y equals 0. So the 0 is plugged in for y on the left side. And now we're going to try to solve that for x. So adding 2 to both sides, I get 2 equals negative 2 times x minus 1 squared. And now to get that negative 2 out of there on the right side, I'm going to multiply both sides by the reciprocal of negative 2, so negative 1/2. So that means on the left, I'm just left with negative 1. On the right, I'm left with x minus 1 squared. Now, instead of using the square root property at this point, we should take a look at that and see if that makes sense. X is going to be a real number in order for us to plot it on the x-axis. And notice that on the right side, we have some real number squared, so that's got to be a positive number on the right side. But on the left side, we have a negative number. So there's actually no solution to this equation. So that means that our graph has no x-intercepts. And that seems weird, but it's actually a parabola, so it's possible that our parabola is completely above the x-axis or completely below the x-axis. That's definitely possible. So let's see how to sketch the graph of our parabola. So part E says sketch the parabola and its axis of symmetry. So let's find the axis of symmetry first. The axis of symmetry is going to have equation x equals some number. And that number, since we had the equation in vertex form, that number is h. So in our case, h is 1. So the equation is x equals 1. So let's graph that. There's the vertical line, x equals 1. Now we got the vertex and the y-intercept earlier, so let's write down the vertex again. We found that to be 1, negative 2. That was hk. So let's plot that vertex. There it is. And label that point. And then the other point we already found was the y-intercept. That was 0, negative 4. So let's plot that point and label it. So now really we don't need to find more than one other point. Okay, in the past we were looking for 2 points on either side of the vertex, but really we only need 1 point on each side of the vertex. So we already have the y-intercept, which is on the left of the vertex, so let's get a point on the right, and then we'll be able to sketch it. So I'm going to choose x equals positive 2, because the vertex is at x equals positive 1. Positive 2 is just 1 unit over to the right. And I bet you can predict what the y-coordinate is going to be because of symmetry. probably the y-coordinate is going to be -4 because it's going to be symmetric. It's going to be a mirror image of that y-intercept, but let's see what we get. Let's plug in x equals +2. We get -2 times 2 minus 1 squared minus 2. Well, 2 minus 1 is 1, and when we square that, we get +1. So we do have -2 minus 2, which is -4. So we do get the point 2, -4. Let's plot that and label it. And we connect the dots with a nice smooth curve. Notice that our parabola is opening downward as predicted, and there are no x-intercepts. It never goes through the x-axis. And that's because the vertex was below the x-axis and the parabola was opening downward. So all the other points are even lower than the vertex. So we could have seen that without actually looking for the x-intercepts. But now you know, if your vertex is below the x-axis and it's opening downward, then you're probably not going to get any x-intercepts. And similarly, if your vertex is above the x-axis and it's opening upward, all the other points are above that one, it's probably not going to intersect the x-axis. All right, so that's finding the vertex form of the parabola given by a standard quadratic equation. And you'll have a few more problems to do on this worksheet and in ALEC.